Hello, now we're going to talk about Chapter 8. Chapter 8 is about lean manufacturing and Six Sigma. So we're going to talk about lean and Six Sigma in the supply chain. When we're finished with this chapter, you're going to understand the difference between lean and Six Sigma, which is on your test. You're going to talk about why Six Sigma quality is very important in supply chain. You're going to understand how a Toyota production system is involved. You're going to understand what the difference between lean and the environment, because we keep talking about that in this book. We're going to talk about how we got where we are a little bit. The history of this isn't so important to me. You're going to understand the tools and the terms, and we're going to talk about statistical process control and how that works. So here's a quick outline on slide 3 showing you what we're going to talk about in this chapter. This should take about 15 or 20 minutes. Shouldn't be a super long chapter. So in the 90s, supply chain management combined quick response, which meant that we had a lot of ability to ebb and flow as the market demand changed. Efficient customer response, JIT, which stands for just in time. And the concept of just in time is, if you can think about at your house, you have this much milk left in the refrigerator. You want the next gallon of milk to come when you're almost out. You're not all the way out because you need to have milk in the house, but you don't want to have 4 gallons sitting there because they're going to go bad. So JIT is just in time. And then we're going to talk about Keiretsu. Keiretsu is for sure on your test, so take a note on that when we get to it. And then we're going to talk a little bit about how all these things came together and became what we talk now about lean. Some people talk lean production, some people say lean manufacturing, some people say lean thinking. The lean concept is all pretty much related and similar. So it's basically a concept that says reduce as much waste as possible, and that you will bring value to the business if you can cut out the waste. So people talk about this as the TPS or the Toyota production system. That's where this started. And then early versions also, this is on your test, started in the Ford assembly plants in the United States and in supermarkets. So the question on your test will be about Ford. So definitely be prepared for that. So some key concepts in TPS are MUTA. MUTA is anything waste. Kanban, I'm going to explain to you about what Kanban is. It's a way to tell the system, I'm almost out, I'm ready for the next shipment, or I'm ready for the next thing to come down the assembly line, etc. We'll talk a little bit about statistical process control. TQM is total quality management. That's also on your test. Poka-yoke and Yokoten. So I want to talk to you a little bit about Poka-yoke. Poka-yoke is figuring out a way to make it mistake proof. So if any of you have ever taken a SIM card out of your iPhone, you'll kind of remember that it's not a perfect rectangle. It's a rectangle with one corner kind of nipped off. And the reason it's built that way is so that you absolutely cannot put it in backward. You can't put it in upside down. It only fits one way. The place where the corner is nipped makes it so you have to lay it with the correct side facing to the bottom and with the correct side facing to the front. There's no other way with the way that the bracket in the phone is that it fits. That's Poka-yoke. Making it so that when the manufacturing is done or the assembly is done, there is no way that you can do it the wrong way, because there's either a fixture in place to make sure that you slide it in perfectly or something like that. But that's what the concept of Poka-yoke is. That definitely is on your test. And then Yokoten is sharing of best practices. So if you have a way to do something that's faster or that is mistake proof or that produces a better product, you should share it so that other people at either other workstations or in other parts of the business can use that same idea. So lean, and we're on slide 7, but lean emphasizes reduction of waste. It emphasizes continuous improvement. So if we say that our goal is 95, once we achieve 95, we should set our goal to 96. If we achieve that goal, we should set it to 97 or 96 and a half. We also want to make sure that the material flows within the organization are smooth. And here's what that means. If I have to do a process to something on the production line that takes 2 minutes, then the person before me needs to either have something that also takes 2 minutes, but if their thing takes 4 minutes, then we should put 2 people doing it at the same time so that we keep everything synchronized through the thing. If you think about going through traffic lights downtown, if you hit the first one green and you drive the speed limit, you can go all the way through downtown and never hit a red light. It's efficient. If you have to stop and wait every time before you get the go-ahead to go at a stoplight, that takes a much longer time. So synchronization of material throughout the organization means that everything is manufactured in the most efficient way possible. So if something takes longer, we'd want to put 2 or 3, some number of people on that job so that we have several people doing it at the same time to speed it up, or we want to have fewer people that are doing it so that when they get a few backed up, it all works so that everything's coming off the production line at the end. And then channel integration is making sure that we're working with the people that are supplying us, our suppliers, and our customers, and making sure that we have good partnerships all the way. So if you think about somebody like Amazon can see the inventory at their suppliers, and they also have the ability to give us information as buyers about when our products are going to come, because they have integration with UPS and FedEx and the post office. All of that is a full channel. All right, supply chain management, we should know now that's SCM, talks about the ways that they're going to incorporate lean are through cross-training, which means I know how to do this person's job and this person's job, for example. Making sure that internal customers get what they need. And so that internal customer means if I am building something and that motor is going to then go into a tractor, my internal customer is the person that's going to assemble the tractor. So we want to make sure that I'm getting everything that we need to the next person in the line. Making sure that products are moving through the production system, making sure that we're communicating what the forecast is and what the production schedule is going to be, and making sure we're not ever carrying too much inventory. We have the right amount of inventory, but not too much. We don't want to run out, but we don't want to have too much. Because if we have too much, it's expensive to store, and we're paying the supplier for that inventory before we have the ability to turn it into something that we can sell and get the money for it. So it's expensive to the company to have to float that money. So these are the elements of lean. I think I asked you to come up with a few of these on your test. So you want to call your attention to slide number 9. So we talked a little bit about this earlier, but muta is the word for waste. And so we want to get rid of things that waste time, waste inventory, waste material, waste people. If you think about a Starbucks line, Starbucks does not want you to have to wait a long time. They want to get your order and get started building it or fixing your coffee or your tea as quickly as they can and moving people. So we want to be very efficient. We also don't have a situation at Starbucks where you walk in the store and you go one direction to place your order and then cross back over other people that are placing their order in order to get it. It's one loop. So the people movement is not wasted. So there are 7 wastes. This is on your test. You have to come up, I think, with either 4 or 5 of these, but the wastes are overproducing, waiting, transportation, overprocessing, excess inventory, excess movement, and scrap or rework. So back to our Starbucks example, we don't want to make a bunch of coffee that we're not going to sell. We don't want to have people waiting to make coffee if there are people in line. We want to keep those people that are making coffee going as quickly as they can. We want to make sure that we don't have somebody that has to go all the way over here to get the cream and then go all the way back over here to get the sugar and then go over here to get the caramel sauce. We want to make sure everything is in the right place and nothing is out of order, where everything can be done quickly. We don't want to have anything that is not a value add. So if we're over processing something, that means we're doing something that doesn't add any value to the end product. We don't want to store any excess inventory. We don't want to have any people having to go back and forth. And we don't want to make a cup of coffee that we can't sell because we made a mistake. I ordered it with 2 sugars and somebody put 2 Splendas in it. I say I don't want that as a customer, and they have to throw it away. That is rework or scrap due to poor quality. All right, this is also on your test. In Japanese, these 5 words that you see in column 1 under Japanese S term are known as the 5 S's. And these have been translated into 5 S's in English. So not exact, but what they're basically about is being organized, tidy, keeping things clean, and keeping things very disciplined about how we do things. So you can see on the right-hand side, sort, set in order, sweep, standardize, and self-discipline. So that's what the 5 S's are. These are all part of lean. On slide 13, you can see that lean thinking is about smaller quantities. That's a test question, that second bullet. It's about smaller quantities. We want to develop relationships with our suppliers across the supply chain, so both our customers and our suppliers. And we want to make sure that we have production or warehouse facilities close to the key customer. If you think about how Amazon does business, Amazon doesn't ship everything out of a central warehouse in Seattle and hope that they can get everything to their customers the next day for Prime. They have warehouses all over the country, so if I place an order, they can fulfill my order out of Sealy or out of Katy, and they don't have to try to get something here from Dallas. If they do have to get something here from Dallas, they know that, and they know that they might have to tell me that it's 2 days instead of 1 day, or etc. They can tell you, yes, this is available for Prime, or no, it's not. Lean layouts, I'm going to show you on the next slide here, but lean layouts are about making sure that you can get everywhere. If you think about your Starbucks again, all of the sauces, so not sauces, but the flavoring. So if you want a pump of vanilla or a pump of cinnamon or whatever, all of that is together and everything is very organized close to the barista. All the food is together, and behind the cabinet that has the food in it is the microwave if it needs to, or the oven that has to be heating it up. Everything is efficient. People don't have to go around. So let me show you this U manufacturing cell on slide 15. What we want here is that the material is going to go in on the left side. So I don't know, let me see if I can get a mouse here. Right here on the left side of this purple line, this person is going to do a process to it. It's going to go to this person. They're going to do a process. Then this person's going to do some manufacturing, and it's going to come out. Everything goes in one direction. We don't have a situation where it's going from here to here, back, over to this person, and back. Everything is going in a very smooth flow, and ideally, the raw materials would be kept over on this side of the warehouse, and this would have a direct path out to where we stock things that are going to be shipped. You can read all this. Excess inventory is a waste. Reducing inventory is how we can get into trouble where we go to make something and we don't have it. So if you said at your home, I'm not going to spend more than $50 on groceries this week, but you could turn up where you'd say, I'm ready to make a sandwich and I have bread and I have peanut butter, but I have no jelly. So that's a problem. Once you know that that's a problem, you can solve it, but you may be sitting there trying to manufacture something and you don't have enough material to make it. You do not need to know anything on slide 17, so don't worry about that. On slide 18, we talk about small batch scheduling. And so if we make things in small batches, we can do things very quickly. Small batches are accomplished with the use of a Kanban. A Kanban says, I am about to finish making my sandwich. I'm about to put the 2 pieces of bread together and put it in the bag and slide the zip closed. So as I'm putting it into the bag and sliding the zip closed in a Kanban system, that would trigger the person next to me to send me the tray that has the next 2 pieces of bread, a container of peanut butter, a container of jelly, and a knife already ready so that I can make the next sandwich. And as I finish that one and I'm about to seal it, the next one would come along the assembly line. The Kanban is a way to tell the next station that you're ready to pull the next batch of whatever you're supposed to be making into your workstation. So this is confusing, so I'm not going to use this example, but basically what this is telling you is that if we can do these things quickly, we can have short setup times. It doesn't take a lot of time to set things up if we're going to make a lot of things very quickly. So this isn't a good example on slide 20. It's from figure 8.4 in the book that shows you how a Kanban system works from manufacturing cell A to manufacturing cell B to the final assembly line. So everything on the final assembly line is pulling from cell B is pulling from cell A, and cell A is pulling from the raw materials or the external supplies. All of this would be, each one of these would have a Kanban signal to tell the system that the final assembly line is ready to pull from cell B is ready to pull from cell A is ready to pull a kit so that they can, of supplies so that they can begin manufacturing in their cell. You absolutely do not need to know this on slide 21. You never have to compute this. A system on your MRP would automatically give you this. You would never have to do this math by yourself, so don't worry about it. Kaizen, this is on your test. You need to understand what Kaizen is about: continuous improvement. And you need to understand workforce commitment. If managers do not support lean production by making sure that everyone that works on their team has all the tools, all the time, all the skills, all the training, everything that they need to identify problems and help figure out how to fix them, then you have no ability to have continuous improvement. If I said to you, we're making 20 sandwiches a day and I'd like to get to 25 sandwiches a day, if I don't give you any training, if I don't tell you, hey, I can give you a bigger tray to make them on so you can make 2 at a time instead of making 1 at a time, you're not going to ever get any faster. At some point, you can only do it so efficiently. You need additional skills or additional training, additional tools, time, whatever it may be, to become more efficient. And continuous improvement is about doing that. And workforce commitment is saying that the manager has to be responsible for enabling the employees. We said this on another slide, but in lean manufacturing, employees are cross-trained. You know how to do different jobs besides just your own. You're expected to do a lot of quality checks to make sure that you're not adding value to something that is not up to quality. If I get the first piece of bread for my peanut butter and jelly sandwich from the person before me and it's supposed to have jelly on it and it doesn't, I should stop. Because if I put peanut butter on my bread and put the sandwich together and put it in the bag, when it gets all the way to the end, they're going to say, there's no jelly here. Take this back and start over. That's a waste. What we want to do is I need to say, hey, stop. You forgot to put jelly on. We need to fix it right here. And we need to figure out how was it possible that that person didn't put the jelly on it, because that should have been part of the process. So there's some kind of a breakdown. Lean, green, I've told you almost in every lecture, this book loves to put everything about the things that are green. Lean, green practices are about how much does it cost to make sure that we are environmentally responsible and that we manufacture such that we are not harming the environment. So 6 Sigma, this is very important. It is on your test, and I want you to understand 6 Sigma and lean are not the same. 6 Sigma is 99.99966 of the time what we produce will have no quality defect. That means if we produce 1,000,000 parts, 1 will be defective, 10 will be defective, 100 will be defective. Whatever that number is, we want to look at that 99.99966 of the parts we create should be without defect. And they call that parts per million. It's kind of like a batting average if you understand how baseball works. It basically says maybe I only made 250,000 parts, but parts per million is a way to calculate the quality to say if I would have made 1,000,000 parts, how many would have had a quality defect. So that's what 6 Sigma is about, having 99.99966% of the parts you create, manufacture, whatever, or the service you deliver have quality that is perfect. You do not need to know this, but this is what this is: defective parts per million. This is how this is calculated. So if you understand statistics, you can understand this, but you don't need. This is not on your test, and this is not something you would need to know. Again, this would be something that would be calculated automatically by your quality management system. So some people combine 6 Sigma and lean, and they call it Lean 6 Sigma. Lean 6 Sigma is putting the two things together and saying, I want high quality input materials. I want good raw material. I want work in process and finished goods. All of that should be wrapped with continuous improvement, or what we call Kaizen. And you need to know Lean and 6 Sigma are not competing. So that's very important. Some people think that if you embrace 6 Sigma, you don't embrace Lean. And if you embrace Lean, you don't embrace 6 Sigma, and that is not true. This is some information about how this works. And so what the goal of combining these is to have fewer negative, when they call it a chain reaction. A chain reaction is what I said earlier about I get the bread and it doesn't have any jelly on it. I should stop. I shouldn't continue to make the sandwich knowing that it's not going to pass quality check at the end. And then 6 Sigma says we need to be committed to excellence, and we need to make sure every supplier, every employee, and all of our customers understand that we're committed to excellence. This is on your test as well. W. Edwards Deming is a gentleman that's considered the father of quality, and these are his elements that he says, they call it the 14 points. He says everyone in the company should have a constancy of purpose to improve the product and get the service improved. They should want to adopt this new philosophy. They should not depend on mass inspection, because you shouldn't have to inspect everything that you make, because you should build quality into the process of manufacturing so that you don't have to worry about that. You should not award business based on price. This was in your very first video. You had a question about this. You should constantly be improving. You should train people on the job. You should institute leadership that embraces these. The most important thing on here is number 8, which is drive out fear. That's on your test. Driving out fear means I should not be afraid to stop the production line if I see something unsafe or something that is bad quality. You want to break down the barriers between departments, meaning that marketing doesn't blame sales, manufacturing doesn't blame quality or engineering, things like that. We don't want a bunch of things that say, make it happen, or whatever, those kind of slogans that nobody is doing a better job because there's a poster up that says, make it happen. We don't want to tell people that they have to produce a certain number of something every day. We want to make sure people have pride of what they manufacture, that people have the ability to get training so that they can improve themselves, and that everyone in the company is accomplishing the transformation, that it's not just relegated to the quality team. The most important thing on this slide is number 8, drive out fear. You definitely are going to have to come up with some of these. And this is another philosophy by a gentleman named Crosby. So he says, the definition of quality is that it conforms to the requirements. So if I say the cookie needs to have 17 chocolate chips in it, and that's the definition of a good cookie, what if I make the cookie with cement and 17 chocolate chips? It conformed to the quality. It had the right thing. It didn't say anything else. So that's a very bad way of defining quality if you don't have enough quality elements. Again, the system of quality is prevention. We want to prevent errors from occurring. The performance standard should be that every product should be perfect. 0 defects is the bottom line. And then the measure of quality is how much does it cost us when we have something that does not conform. So if we say, this cookie has everything, all the 20 elements it needs. It's delicious. It's crispy. It's this, it's that. It has everything perfect. But if it only has 16 chips, what does that cost us? Can I go back and add a chocolate chip to an already baked cookie? No. So I have to throw it away. So whatever it costs to make that, that's what the cost of nonconformance is. You can see this here on this little more information on Crosby on 31. Urine, that's how you pronounce this, urine, talks about quality planning, quality control, and quality improvement. There's one question about that on your test. There is some one question I just want to talk to you about the Malcolm Baldrige Award. Is a very well-recognized award that's given to large companies. They can apply for it. It's extremely expensive to participate in the Malcolm Baldrige competition, but you are awarded, and it is a very, very prestigious award if you're awarded the Malcolm Baldrige Award. You need to know the difference between 9000, ISO 9000, and ISO 14000. 9000 and 14,000 are both on your test. You need to know the difference between 9,000 and 14,000. 9,000 is about manufacturing. 14,000 is about environmental certification. All of ISO standards are voluntary. You do not have to be certified, but many companies will tend more to do business with you if you are. A way that you can do better to improve in Six Sigma is what they call the DMAIC schedule, which is cycle, not schedule. Define the problem, measure the results, analyze, improve, control. So if you think about this, my goal is I want to lose weight. I need to define that I want to lose weight and figure out what I want to do about that. I need to measure, so I need to weigh myself every day or every week or every month. I need to analyze. I lost weight. What did I do well that I can continue to do? Or maybe what did I not do well that I need to change? How can I make an improvement? And then what can I do to control it so I keep my weight controlled once I've gotten to my goal? That's what this is. This is more information on that on slide 37. On slide 38, I just wanted you to know that there are, people will tell you I'm a black belt, Six Sigma black belt. These are ways that you can get certified in Six Sigma, and they call them belts similar to how karate works. But this is because it's a Japanese origination, that's how they do this. The next thing I want to talk to you about is flow diagrams. You've probably seen these a million times. That's a flow chart. A checks sheet, I'm going to show you an example of. I want to talk to you about a Pareto chart. That's on the test. A Pareto chart is and the bottom one, which is called either a fishbone or an Ishikawa diagram. These are really good ways to brainstorm. So this is what a flowchart looks like, or a process map. You don't need to read this. I just want to show you this is what a flowchart looks like. This is a check sheet. So we had problems at our restaurant. What were the problems? On Monday, how many times did we have a long wait? We had 6 times we had a long wait. So you're going to read through this. Now I'm going to show you another way to look at it. This is a Pareto chart. The Pareto chart says, if you look at all the problems I had 100 problems total. You can see on the very bottom right. If I look at this and I say that the biggest problem I had was long wait, what that tells me is if I can solve that problem, instead of having 100 problems, I now have 52 problems to solve. So I can fix the one problem and make all of that go away. This now shows you the restaurant. We have a long wait on Friday and Saturday. That's not surprising, right? So what can we do about that? We need to resolve that one problem, and it's going to make half of our problems go away. This is called a fishbone or an Ishikawa diagram. So if you look at this, you can see it kind of looks like the skeleton of a fish. And the reason it's called that is this right here would be like the spine, and then these would be gills or fins off of the fish. So what they're saying here is every time we say we had a long wait, why? Was it, let's look at the bottom, manpower. Okay, why? And every time you ask why, you put another arrow pointing in. This is how you can brainstorm how to resolve a problem. So fishbone diagrams are very valuable, or that some people call them Ishikawa diagrams. I did not put anything on your test about statistical process control. This is all formulas. I didn't put anything. Here you can, that's the end of the chapter. So Ishikawa is the last thing that you need to know. So definitely a lot in this chapter to digest. You may want to go back and listen to this lecture again. I know it's about 25 minutes, so shouldn't be too terrible for you if you have to listen to it more than once, but definitely there's a lot of content here that's on the exam.